Alright, so today we took a look at projectile motion, but only when the projectile is launched horizontally. Okay, and so a projectile is an object that is thrown or launched, and then you don't touch it again, and the only thing acting on it is gravity. So a projectile is basically in free fall. The only thing causing its motion to change is gravity. The difference between this and the stuff we were looking at before is that now we have two directions we've got to keep track of, right? Before we had cars moving down the highway, they were moving horizontal, we can compute things with that. Or we had balls being tossed straight up or straight down, just vertical, we can deal with that. But what happens when we have motion in two dimensions? Okay? So this is sort of a new topic because all of a sudden we've gone from just moving up or moving left and right to moving in both directions at the same time. The trick to doing any of these problems is to make sure you keep those two motions distinct and separate. Okay? For instance, if I roll a ball off a table, okay, the ball, say, has an initial velocity off the table, horizontal, 10 meters per second. If I drop an identical ball at the same time as this one's going that way, they'll hit the ground at the same time. Okay? That's because the only thing that causes them to fall down is gravity, and gravity pulls on them both the same. Okay? So, but instead of this ball dropping straight down, okay, we're going to have the ball that follows sort of this curve down to the ground. And so the question's going to become, how far away does this thing land from the edge of the table? What is this change in position? I need to know that. Okay? Well, that's a change in x, not a change in y. So we're going to keep these two separate in every single problem we do. Okay? When we have two directions, we have to have two directions. X is one direction, y is another. X is horizontal, y is vertical. Okay? So here's x, here's y, and those are the positive directions in both. So, what do I know? Do I know an initial velocity? In x, the initial velocity is 10 meters per second. Okay? But in y, the initial velocity is 0 meters per second because the ball isn't moving up or down, it's rolling across the table. Okay? Let's say this table is 2 meters high. Then I know an initial position, okay, in y. We'll come to that, I guess. Let's get to acceleration. The acceleration in x, well, is there anything causing it to speed up or slow down? Well, no. Okay, so its acceleration is 0. The acceleration in y is g, which is negative 9.8 meters per second per second. Okay, and now I'll talk about initial position, x naught. Okay, I don't really care what it is, but I can call it 0, the edge of the table, right? I get to pick it, I can pick my reference, so there's 0. Y naught, though, it starts 2 meters high. X final, I don't know that. I would like to figure that out. Y final, I do know. It ends 0 meters high, it ends on the ground. Okay? And the other thing I can talk about is time. Okay? Now, the cool thing about time is since the ball is moving in both directions at the same time, the time is the same for both of these problems. So if I want to know how far away the ball lands, okay, what I really want to know is x, which equals 1/2 at squared plus v naught t plus x naught. Well, this is 0, this is 0, so I have x equals v naught t, okay, but I don't know time. However, if I come over to the y direction and I say the same equation, y equals 1/2 at squared plus v naught t plus y naught, okay, then I can say final position 0 equals negative 4.9, right? That's half g t squared plus 0, because it wasn't moving in y, plus 2. Okay? And so then I can subtract this over, or add this over, I guess. So 4.9 t squared equals 2. Divide both sides by 4.9, and t equals 2 divided by 4.9 square root. Okay? Well, that is the time it takes for the ball to get, wow, that is the time it takes the ball to hit the ground. So whatever this time is, once I solve for it, I can put it back in over here and get the change in position in x. So the trick to any and all of these problems is to keep your x and y motions independent. Okay? X and y motions will be independent. You don't intermingle them, and so it's important that you set it up. You have your x motion, you have your y motion. Okay, but you keep the two separate. So you've got to figure out, okay, what's its acceleration in x? It's horizontal acceleration. What's its acceleration in y? Where does it start? Where does it end? How fast is it going? Okay, all of those things, but you have to do it twice. Once for horizontal, once for vertical.